Good morning, everyone. DSCA's National COEs has come up again with a webinar on data sharing and technical challenges and solutions by Professor Sushmita, who is CSIRO at the, Data 61, Australia, and an associate professor at Indian Statistical Institute, Kolkata. We welcome you, ma'am. Ma'am,
thank you.
Now over to you.
Can you hear me?
Yeah, we can see you. You can go ahead with your presentation.
Okay. It's a pleasure to speak here, and a very good morning to all of you. Maybe morning or maybe some other time zone. I'm not very sure.
But it's morning only, ma'am.
Yes, morning. And we will be, what I'm going to talk about today is about data sharing and some of the technical challenges and some solutions that we have. So when it comes to data sharing, we need to note that you could actually have three different scenarios. One where you have data within the organization, which is when you're not sharing it at all, and this is called the closed data. We have another condition on the extreme opposite end, which is actually sharing it publicly with everyone, which is open data, and this is released publicly. And we have the shared data where we have controlled access of the data. Now, one of the things to note in during this talk is that I'm going to discuss only the shared data where we have controlled access. At this point, I'm also going to tell you that we have certain scenarios where we have closed data where it is not at all possible to share, and the organization keeps it with itself, like very sensitive data that has the organization has sole access to. And on the other hand, when we talk of the publicly released data or open data, we need to ensure that when the data is shared, what data is being sharing, and whether certain anonymization is already there in this open data. For example, if you are sharing medical data, you should be able to anonymize the data so that you do not have access to the important information of the patient or any other information that the patient has not consented to be shared or to be publicly released. So I'm not going into that territory at all. That is actually a separate issue in its own right, and there's a lot of discussions to be done in that domain itself. What I'm going to talk about is the shared data where we have controlled access. And let me just tell you a couple of scenarios where this is very applicable and where it has been used, where it is being used quite a bit. So one of the applications is that for example, your transport data, where you typically have data that is being collected from various users for when we get into one of these sharing services. And at all points, it should be remembered that when you actually start sharing your data, you say that what sort of terms and conditions you agree with. And you might be actually giving access to your data to the service provider, for example, be it Uber or be it Facebook or maybe it's the other organizations. And you essentially, when you say that I accept the terms and conditions, that is where you actually give access to your data. And sometimes these policies are explicitly stated, sometimes it is a bit vague. But that is actually another topic where we need to, where there is a lot of discussion and debate what is good, what is right, and what is wrong. And essentially, when you say that I am accepting, it is like you are giving the consent that yes, you are giving the consent for this data to be shared with certain for certain purposes, for certain or to certain organizations, or certain for certain reasons. And if you look into these type of open shared data, it actually has a lot of importance. The reason being that data is used for various purposes, and mostly to make our lives much more easier in terms of making predictions, whether there would be a traffic jam or which road you should actually be taking if you were to drive from the point A to B. Or it could be some data collected from for medical diagnostics that can make our lives much easier by devising a new drug, or it might be making a new by being able to predict what sort of diseases we have. And at the same time, if you notice that there is always this condition to be kept in mind, that if I'm sharing this data, whom am I giving access to, or where is the organization, whether the organization or the with whom I've shared the data is actually taking this data properly and giving it only to individuals or organizations who have been authorized to access. And why is this being so talked about nowadays is because it brings serious implications. It has a lot of implications to privacy. It has a lot of implications to a number of legal frameworks. And I will talk about the GDPR a little bit, and what it means to have, what challenges it brings to data storage. But I would also like to just caution you that some of the data that we are sharing with certain individuals or with certain organizations, we have no clue what is happening to that data. And we have recently seen the Cambridge Analytica scandal, where some of the data in the Facebook were being shared without our knowledge. Another topic that I will actually be touching upon is data trading, where which means that you can actually trade data for certain benefits. And why is this important is that because your data is like currency, and it is very, very important for various organizations, because these organizations are actually making big business out of the data that we are actually sharing with them. So I will touch a bit on data marketplaces and what its significance and how it applies to our to us. There has been quite a few data breaches recently, in the recent past, and that brings us to the question that how can we one side prevent such data breach, but on the other side, how can we ensure that even if such data breaches appear, it's not going to create as much trouble for the people at stake. So what it means is that at one point of time, it means that we need to put some measures into place so that the data breaches do not happen at all. But this seems to be a very difficult problem to solve. So one of the other things that people are also trying to do is put up some mechanism or transform the data in such a way that even if data breaches do happen, then the attacker is not able to glean as much information or any information about the sensitive information about the data. And this will deter them altogether to launch a data breach in the first place. And today's talk this is actually, I mean, the whole problem of data sharing is a very vast topic, and it has a lot of correlated and correlated things in place. For example, there are a number of technical challenges here, there are a number of legal challenges here, there are a number of economical challenges here, and also social challenges here as well. So during this talk, I'm only going to focus on some of the cryptographic challenges that are there, and why and how we can use cryptography to address some of the problems of data sharing. At the same time, I would also like to mention that it is not just one problem, or this cryptography does not do away with all the problems that are present in data sharing, or even not even the controlled, or even even if we have some access control in place, it's not going to do away with everything. And it's a large, there are quite a few problems that should be solved hand in hand to make this data sharing process to be smooth and according to everyone's need. So I'm going to talk about some access control mechanisms for data sharing, and some of the mechanisms for data storage, some ideas about what a data marketplace is, and how it is actually reshaping the future of data, and some of the challenges in achieving data sharing, and what are the future scope of this problem. So before I start with each of these problems, one word I would always like to mention is that this is a multifaceted problem. So for a complete solution, there are various stakeholders should come together and solve this. And it is not just a cryptographer's task. I'm a cryptographer, applied cryptographer myself, so I like to talk it from one angle, but there are many other things in place that should be considered together with this sort of an approach. So I'd first like to talk about the data storage problem, which is that how do we provide long-term reliable storage? And this means that we need to keep in mind that servers might not behave faithfully, and they can discard all data or hide data loss, or if the data is deleted, there is no way to recover it. And the clients was there any question or anything at this point? Because I'm not very sure if I'm missing something here. Can I continue?
Ma'am, we cannot hear you.
Okay, can you hear me now?
Yeah.
Okay. Sorry about that. I think there was a temporary glitch.
We can see your screen as well.
Yeah, you can see my screen. Okay.
Yeah.
Okay. Then we are all good. Let me just continue with the talk. So we have this data sharing. We need to address a few things when it comes to data storage and sharing, and one of it is a reliable storage, which means that data should not be tampered at all. Access control, as I mentioned, is that data should be shared only with authorized individuals and not with any other parties. So one has to be very cautious about these practices and put some mechanism in place that would actually prevent data to be shared with unauthorized users. And for various applications and for various types of legal uh, reasons, we also need to ensure that the data resides in the particular geolocation. And well, this is not a very easy problem to solve, and I'm going to talk about some of these, some of the challenges around this. Now, coming to yeah. So there are some of the legal some of the regulations in place that actually put some legal restrictions on sharing data, and these are really important. Why is it important? For technical reasons, it is important because however you are sharing the data, that should abide by these terms and conditions. So there was this GDPR, which was essentially it has been in place since 2018, and amongst various things, it says that it asks for data integrity protection, accountable storage, non-repudiation, and data should reside within a geographical location. Data should breaches, as I mentioned, should be reported. And there is also a tenet which says the right to be forgotten. I have actually mentioned it in blue because this is a problem I will not answer in anywhere in this talk. And from the Indian context, we have our Indian Personal Data Protection Bill, which has been formulated, which has many of the features that are present in GDPR. And this was presented to the Indian Parliament on 11th December 2019. And amongst various terms and conditions, it also asks for data protection, perform data audits, share data, or it has some restrictions on where the data should reside. And it has also the same conditions on data breach and right to be forgotten. When I talk of data auditing, what does it mean is that just like we have audit for various purposes, data audit essentially means that it is also a periodic activity that will assess the quality and the utility of data. And amongst various things, it will ensure that the security is taken care of, the data integrity is taken care of, there is privacy, there are computational accuracies that are that should be present. And not only that, we need to provide certain proof that the data integrity is protected. There should be some proof of geolocation, some proof of erasure, that the data that I have requested to be erased is actually erased. This is a very difficult thing to do, but this should actually be there, and it should protect against data breach. So what I'm going to talk about is just touch about how we have proofs of integrity and how we can protect against data breach. I'm not going to talk about how we can ensure in a using technically using certain computational techniques or techniques to how to protect the how to give proofs of geolocation and proofs of erasure. And there is also an importance for proofs because these are mathematical guarantees against cheaters. And imagine that if you had any kind of a dispute, you would essentially go to the court of law to settle this dispute between, say, a data owner and maybe a service provider. But if we do not have this type of in the absence, or if we do not want to go to the legal ask for legal help, is there a mechanism to do it automatically? or is there an automated way of taking care of this or emulating the court of law? And that is why we try to come up with some mathematical proofs to guarantee against cheaters. I mentioned about data breach, and Article 32 of GDPR says that data should be encrypted and pseudonymized and encrypted where possible. I'm not reading out the entire thing, but the important thing to note over here is that it should be pseudonymized and encrypted. And 34 says that we should actually render the personal data unintelligible to any person who is not authorized to access it, such as encryption. And this is essentially really important because there are certain challenges when we talk about encryption. And one of the challenges on encrypted data is that mostly we are doing various sorts of computation on this encrypted data. And one of the things that we need to remember is that if we encrypt the data, then computing on encrypted data becomes all the more difficult. So imagine that you have the data and this is stored in some server, which might be a cloud, and it is encrypted. And now if you want to even ask that, make a simple query on this encrypted data, it is not a very trivial task, because the server is the data is now encrypted, and the normal search query has to be translated into some way in order to be able to access and return the correct results from the encrypted data itself. So there has been a lot of work that is done on this computation on encrypted data, and similarly on various types of queries, especially even the search type of query that were very that is actually not very simple in itself. If you consider millions and millions of records, it becomes all the more complicated if this search is being done on the encrypted data. Not only would we like to have the security and privacy in place, but we also need to ensure that these solutions are efficient and scalable. So the technical challenges here are to ensure the security of data, to ensure that the solutions are scalable and if efficient in practice. And similarly, we would also like to have access control on encrypted data, and this is something that has been widely studied and continues to be an active area of research. We have done quite a bit of work in encrypted data encryption, and some of the work that has been done use a technique, the cryptographic technique called attribute-based encryption, and there has been quite a bit of work that we have done also on data analytics on encrypted data. And the same problem that you do in analytics become even more difficult with encrypted data. And I suggest that you can have a look into some of these technical papers on predicting on secure link prediction, as well as also various types of encryption on various types of search on encrypted data. So with that, I will talk about access control at a very high level. I have no clue of my audience, and I believe that I will just give only a high level description of some of the techniques that we do in using cryptography, and I will simply touch upon the schemes. There has been entire body of research that has been done in this domain, and it is very difficult to speak about everything in this 45 minutes talk. So imagine that you have medical records, and you would like to there is a patient who would like to give access to this medical data to only selected groups of individuals. And suppose here only some hospital staff or researchers or doctors. And also from another perspective, if you to be a social network, you would like to actually give access to your personal information only to certain members and hide it from the rest. So there are different ways of doing access control. One of it is a user-based access control, where you have the access control list attached to the data, which essentially says who are the users who can access this data. We have role-based access control, where access is based upon specific roles. And it does not, it is a good way of handling problems where we say that, these records should be accessed only by doctors of a certain hospital, or these should be accessed by certain researchers or certain organizations, but it does not essentially give a very fine-grained access control. And in order to provide access control, fine-grained access control, we would like to associate some attributes to the data. And we might essentially say that the access rights might look as a researcher or a neurologist at hospital A can access this medical data. And the patient can come up with this kind of access policy and attach it to the data. And the whole idea is to encrypt the data in such a way that only people with these access rights, or who have these attributes, the people with only these particular attributes of a researcher or a neurologist at a particular hospital, are able to decrypt this data. The good thing about it is that the patient actually encrypts the data only once, and anyone with these attributes can actually decrypt this information with certain cryptographic keys. So this is broadly the idea that we have a key distribution center which actually generates the cryptographic keys, and it gives each of the sender has an attribute associated with it. And what it does is that the public key is a function of these attributes. The sender actually computes a ciphertext, which would be the message M, some of the attributes, and some of the policies that the user would essentially have. So in the previous case, when the sender or the patient can have this kind of an access policy, which is here represented by a tree, and or say that this tree essentially tells us that this is the policy that is associated, and it is some function of the public key. And I'm not essentially describing what this F function is or how it looks like, but this is a function with the message, the attributes, the public keys, and the access policies. And the KBC actually gives a secret key, which is also a function of the various attributes to the receiver. And the main idea is that when the sender encrypts this message using the policy as well as the public keys, then the receiver can decrypt it only if it has a matching policy. For example, it has this policy N and A. So if you see that this N and A, so this AND condition is satisfied and this OR condition is satisfied, so this means that this receiver will be able to decrypt this this message M and get back whatever it had asked for. But this problem gets very, very tricky, because sometimes these there are and I will also mention over here that this is an entire body of literature on attribute-based encryption which actually does it. And I have just mentioned one work here, but there are, almost I think thousands of papers now on, or even at least 1,000 papers, or maybe a few hundred papers on this attribute-based encryption, which actually solves various problems, tries to make things efficient, tries to have stronger security guarantees, and try to have more functionalities with this whole system. And I would just like to mention is that one of the things that we did in one of our work with the Shorojoi collaborator was to look at how this can be done efficiently, and we took the help of two mechanisms which would actually help in partial decryption. So just a note on this is that these type of techniques are very sometimes inefficient because there are a lot of overheads involved in the encryption process as well as in the decryption process. So if someone can make this encryption faster and the decryption faster, then these can be very suitable even in case of the mobile devices as well. And one of the things that we did was to make these techniques much more efficient so that you could do the encryption and decryption from using mobile devices as well. So if you have resource constrained devices, this would also be very, very fast and very, very, and at the same time, they would have the same security guarantees as a normal procedures. I'm not going into the details of this, but it is essentially possible, and the direction of work is that you make the techniques much more efficient by dividing it into several stages, where you do some online computation and offline pre-processing, or take the help of certain proxy server who would do partial decryption, decrypt it partially without even understanding or being able to get the complete plain text message from the ciphertext message. The next problem I'm going to talk about is how to do data audits. And if you try to think of a data audit, it would be like, what is an audit mechanism in the first place? And we handle only one type of an audit, which is actually the integrity check. And one of the ways to do an integrity check is that if you have a big file or a big message, you break it down into smaller chunks and you send it across to the server. And you can actually ask for random indices that you have maintained with itself. So here on the left, you see the data owner who has kept with himself only a few blocks and sent the bigger file to the cloud server. And what it does essentially is to randomly choose certain indices and ask the server to say that, yes, have you kept my data, have you kept this data blocks M1, M4, and M9 correctly? And by looking at these blocks and comparing with what he has, he is able to quickly guarantee that, yes, this is right or wrong, or the or the service provider has maintained the data correctly or in an incorrect fashion. The main problem with this approach, if you look, is that it is rather slow, and slow in the sense that you have to download quite a few blocks of data, and you also have to, the client or the data owner has to maintain quite a bit of information. There has been a lot of work which has been done in this space, and one of the ways is to look into traditional proofs of storage, which are able to give guarantees that the server is able to prove that it actually possesses the client's original data. So what typically happens is that along with to protect or to reduce the load on the data owner end, what happens is that the data owner also signs each of this, or either keeps some tag or authentication tag sigma I for every message mi, and stores this information in the cloud server. And the same process continues, that it randomly chooses some indices and asks the server to return the message and the tag, and verifies whether the tag sigma I is the correct tag for the message mi. And the only thing that you have to ensure at this point is that the sigma is an authenticator, and it's unforgeable in the sense that you will not be able to construct any mi sigma I pair, even if you know some of the existing mi sigma I pairs. You will not be able to construct any new pair or forge such a message signature or message and tag pair. Now, if you look at it, here you would need no storage at the data owner's end, but you would still need considerable amount of communication. You will still incur a considerable amount of communication overhead for getting this mi and sigma I. And what you could also do is that, I'm not going to talk more into details, but if you would like to recover the data in case there has been certain failures, you could also incorporate this in this type of technique. Note that this, when I say the proof size, it essentially means that the information that the server sends as a response to the challenge set indices is actually proportional to the size of the query. So if you send, say, n indices, n random indices, then you will get a n size. The size of the query is of the order of n as well. Now, you could possibly delegate this auditing task to some third party, but you need to ensure that the third party auditor does not get the original message, because then it would mean that you are leaking some information to the auditor. So now, if you look into the technical challenge, then the technical challenge is to ensure that how you can reduce this communication overhead for this response protocol. And there has been ways of doing it. I'm not going to the details. There has been a body of work on this in this domain, and you can actually refer to the paper here. What we did was to look into techniques where it is important that the data owner also stores where the data is actually changing, or you can simply, for static data, it looks all good, but if you have a dynamic data, then it does not look good. And the reason being that you could have you do not know, I mean, whether even if you send a correct, even if you add this block, say M4 sigma 4, if it is corrupted, even the data auditor might essentially try to send some old block which was already stored in the service provider's end, M4 sigma 4, without even modifying, sending the modified one, M4 sigma 4. So if you have modified this block M4, if the data owner has modified this and the cloud server has not modified it, it can still pass the check. So one of the directions for work is how do we do these sort of protection. And I'm trying to essentially, I'm not going into the details of these schemes, but just trying to mention that when you discuss, or when you try to design these schemes, it is really, there is no like a single formula that it is this, just put this tool and add this tool and run this computation or call this function in some from some black box and do it. So these are to be designed. properly, keeping in the security in place. So it is a little bit different from using or trying to use some existing tools that are already mm, some of the what would I say, the analytic tools that you typically have. So this whole area would require that you actually use some of the building blocks, very simple building blocks to very complicated building blocks. For example, simple building blocks would be like your authenticated data structures, and some of the complicated ones would be like various types of signature schemes, various types of message authentication codes that you use for generating the tags. I'm not going to talk about all these results, but the last thing I'm going to talk about is the data marketplace concept, which is a very interesting concept. And I will not talk much about the blockchain part of it, though you can refer to it, but I'll just quickly tell why blockchain could be important for these sort of problems. And before that, maybe I'll talk about what a marketplace essentially does, or a data marketplace essentially does. So you have a set of buyers and sellers. So sellers are the ones who would like to sell their data, and they would upload the data to get some revenue in return. And the buyers would like to download this data for some after paying some fee. And there is this host who actually hosts this market, and it is like any other marketplace that you have, like Amazon or Flipkart, where you actually trade different items. This is essentially trading the data, and this makes more sense nowadays because we are all generating a lot of data, we are giving out a lot of data, and it is very important to know that it is important to get some benefits in return. And it could be a benefit like you get better services, but you could also get a better, you could actually get various types of points or money in return for the data that you give. And this is becoming more and more useful nowadays. And just, I mentioned that there are some owners and sellers. So this means that the owners themselves could be sellers, or they may actually, the data owners who are actually holding the data might actually give it to some third-party sellers to initiate this kind of a trade. And a lot of things are really important when it comes to these sort of marketplaces. And one of the things is the fairness, which means that whatever price you pay, or each of the parties, so the buyer pays, is actually fair, and it gets the content in return, and the seller also gets the correct value, and this middleman, who is actually this marketplace, does not cheat in this process. This is actually true for all marketplaces. You wouldn't like that, you do not get the money, but you still you do not pay the money, but you still get the service, or get the product. So just like that, this sort of data marketplace also needs this fairness guarantees. There should be some transparency mechanism, meaning that the seller is aware that, yes, this is the content that I had sold, and someone has bought it. And if I see that it has been this piece of music, or this piece of data has been downloaded, say, or been given to, say, 100 people, I should be able to get some revenues from each of these 100 people. And not that the marketplace can tell me that, no, this has not been downloaded much, it has been downloaded 10 times, so you do not get much, you get only, it's not as popular, so you get much less than what you deserve. And all these things should be in cooperation, or in under proper regulations, be it the GDPR or the or other data protection regulations. And this should be efficient in terms of the conventional protocols. It should not be that I'm being stalled and I'm waiting for this data to be given to me. I should be it should be it should be done in real time, I should say. And it could be the data could be in the clear. When I say it would just could be the data, just like files, pieces of music, streaming videos, or so on, or it could be some analytics that is done on the data. So this is what I mentioned, and maybe in the last 2-3 minutes I'm going to talk about why this fair trade is not a very simple thing to do, because fair exchange is impossible without a trusted setup. Why is it so? Because I'm giving you the money, and I'm giving you the product. You can actually take the product and not pay me back. And then whom do we go to? We go to the court in order to settle it. And so there is some trusted party whom we go to in the hope that this will be resolved. Any disputes that arises will be resolved. And I'm going to, there are different ways in which we could actually design this trusted party. And one of the ways to design the trusted party is to use a blockchain. And I'm going to talk a little bit about the blockchain in this case, which is a distributed, verifiable, immutable ledger. And what it does is that it can not only just record all these transactions in terms of who gives whom what, but it actually keeps a track of all these transactions, and none of it can be changed. That is where this immutability comes from, and whatever has happened can be verified. And typically there has been a lot of discussions around blockchains. I'm not being able to see my audience or even know who the audience is, so that I'm able to discuss or more into details of these blockchain based solutions. But at this point, what I would like you all to understand is that this is a blockchain which typically which we assume to be trusted, because it is maintained by various peer nodes, a lot of peer nodes. And we assume that we have that the majority of them are honest, and the blockchain platform is behaving honestly. The good thing about the blockchain is that just like we have contracts, like I give this product and I get this money within a certain period of time, maybe within 1 day, and if I do not, I have certain penalty or some other mechanism to handle it. Just like normal contracts, these blockchains are able to run smart contracts, which means that every node is going to run the smart contract. Means that even if someone misbehaves, you will be, the majority of the peers will run them correctly. The third reason why we use a blockchain is that the incentive mechanism is properly distributed. The difficulty with the designing these marketplaces are that just like contracts or whatever terms and conditions are there in any contract, it is very difficult to code them in a proper way in these smart contracts. And that is one of the big research challenges that we have. How do we compare it? How do we code it as smart contracts and ensure that these contracts are automated, this automated checking is done? Because the first thing to do is to translate a text, a natural language, text written in natural language, which is a contract, to something which is an automated, which is actually a smart contract, because this is to be completely unambiguous, whereas the text in natural language often is ambiguous. So with that in mind, I'm not going to talk in details about the protocol that we have, but to make a note of it, that it is difficult to achieve fairness. The reason is that we need to ensure not only do the parties get their proper share, it also has to consider how we are going to ensure that ensure this fairness, and that is why a lot of research is actually being done in this domain, using various techniques like zero knowledge protocols for preserving the privacy and with that comes also the question of efficiency, because many of the cryptographic techniques are not as fast. And we would like to have verifiability on this encrypted data, which means that if I am giving you some results or analytical results, you should be able to figure out that, yes, these computations have been done properly. And the last thing is, or the most important thing is that, as I mentioned, is to codify law. So with that in mind, there are a lot of things to ponder upon when we think of data sharing, just and beyond data trading. And this would involve audits, this would be anonymization, this would have access control, this would have analytics, encrypted analytics, and various types of various privacy preserving analytics to be done, or query processing to be done on this data. Having said all of this, I would actually mention one thing over here, that throughout the talk I have only tried to talk about the cryptographic challenges here, and I've not touched upon various other ways of, when I say anonymization, there is a lot of work that is done on anonymization techniques using various techniques like k-anonymity, diversity, and also a lot of literature on privacy preserving technologies I have not touched upon at all. And these are very crucial when it comes to data sharing. So the last take on things is that there are a few things to remember, just reiterating what I mentioned during the first part of the talk, is that this problem of data sharing is not just a technical problem, it is actually a problem of various domains. In this talk, it's only cryptographic techniques, but there are various other techniques in place. And one thing, the takeaway is that various types of the communities, be it the software community, be it the research community, the policymakers, the legal community, as well as the social, as well as various other communities should come together to solve this problem of data sharing, to make it much more suitable from the point of view of privacy, from the point of view of efficiency, from the point of view of legal compliance. So with that, I will end the talk and take questions if you have. Thank you.
Thank you, ma'am, for giving such an insightful and knowledgeable talk. So we don't have much questions, but we have a very interesting question from one of our attendees, where he says, when the researchers want to work with the private data featuring engineering becomes a challenge. You are unable to explore the data well in the case of federated learning. Has there been any progress made in that sector? Something maybe like generalizing some feature engineering in client side itself so that we receive the private and the encrypted data in the way we want.
Okay. Yeah, there has been a lot of work being done on federated learning. And just to tell you that the whole purpose of federated learning is actually to protect protect, to do this privacy preserving machine learning. And one of the things to understand when it comes to federated learning is that there are a large number of challenges that are present in federated learning itself, and it has been abused quite a bit. So I will suggest that if you would like to get insights into the individual, I mean, that is actually individual, what would I say, individual the features or something, that is actually not the purpose of federated learning. It is just to obscure that, actually. I'm not very sure if I answered the question correctly.
Yes, ma'am. Thank you so much. So we don't have any more questions yet. While the people are liking your talk, so there has been a comment like very nice talk. Not guys, if you have any more questions, please feel free to ask. You may post your question in the question column.
Okay, I think
There
if there are no
no.
other questions, then we can close the.
Yeah.
Thank you very much
Thank you so
for.
much, ma'am. Thank you, everyone, for attending this webinar. And we would look forward to have you again as a
Thank
speaker
you. Thank you for
and as an
inviting me.
attendee both.
Thank you for inviting me, and have a good day.
Thank you, ma'am. Have a good day
Bye.
to all of you. Bye-bye.